fairly easily. And
so I can take it back over when you're ready to.
I'm ready.
Finish. Okay.
Unless anyone has any questions.
Yeah. So yeah. Oh, go ahead.
Actually, look, there's a good tutorial going on here, right?
Just a quick question about that. The Linux server you could put in as a line card, you said it has a direct path to the switch CPU?
Yeah, it has a direct path to the switch. It's basically a 1 gigabit. Is it 1 or 10 gigabits? I should look up the spec. It just got a direct path right at the switch chassis. So it's really, really nice. I mean, there are people who are doing an awful lot of interesting things with that.
So
there's not much of a CPU on it, but hey, better than the switch.
Thanks, Rick. I appreciate that. So now I want to get into showing you the little kind of canned experiment that we've actually got going on here. It looks to me like about half of you have gotten to this point. If you have trouble catching up, we still have people who can help you figure it out. Oh no. It was away for just a second too long. Okay, now if I look, so one of these nodes, so the experiment that we have set up, it's extremely simple. It has a source and it has 2 routers that are also acting as sinks for packets. So if I go to this source node and I click on the little information button, you'll see there's this button now here for visit and SSH. Actually, let me show you one more thing about it before I go. So you'll notice that there's a bunch more information next to these machines now. So you can see, if I drag this apart, that this top machine ended up on PCVM 1-2, so it got put on PC1 on this rack. This one got put on PC5. This one got put on PC3. You can see the OS image that got used. It's an OpenVZ container. And these things, I'm sure you can't read this, but when it comes up on your screen, there's a port number here that's actually the port number that I would use to SSH into them. So in my canned experiment, these 2 machines did not request public IP addresses. So I can get to them, I can SSH into them on this strange port, but I'm not going to be able to really run a web server or anything on them. This guy up here, I did ask for a public IP address because I'm going to use it as a web server. And if I click on this little I button, there are a couple of things I can do here. So one of the things I can do is I can click on this visit button, which opens it up in my web browser. And so our little example tarball has set up this little web server. This thing is it's currently sending some traffic. I've got some controls to start and stop it and to change the routes. The other thing I can do is that I can SSH into it. So if you look at your sheet, there's a command on here. So normally when you create an account, you would upload an SSH public key. If you are using the VM, we have preloaded the SSH key for your account on the VM, and there is a command that's in the middle of the handout about how to set up your public key. So I'm going to go ahead and do that now. Let's see. Go out of full screen, open up a terminal, and so the command is ssh-add.sh, and then my username, which for me I'm using the GEC15 account. Oops. Nikki, I didn't get this command wrong, did I? It's
it should be under USR local bin, I'm guessing the one.
It's in your path, just take off the .sh at the end.
Oh.
No, but this is the actual SSH tab, that won't work.
No period.
Oh, yeah, you're right. Okay.
The command could be add. Does it? It should be under USR local bin.
I tested this.
Can you just
Yeah.
without the SSH? It shouldn't have so many stuff. Yeah, it's not here. I have no idea.
Is anybody else? I don't have the final version of the VM. Does anybody else?
Don't you need to change directory into the tutorials?
Okay, well, I'm not going to spend too much time messing around. Okay. Just a minute. Okay, so I'm very sorry. I actually put the wrong thing on the handout. Very, very, very sorry about that. So the actual command is is add-key.sh. Sorry about that. I thought I tested it, but apparently I missed something. So add-key.sh and then your username. And this will ask you for a passphrase. It's the same passphrase that we used earlier when you had to type it in the login box. And that will set up my keys. If you don't get this step set up, this is not critical. You can still view the rest of the tutorial. And so now once I get that set up, I can click on one of these nodes and I can click on the SSH button and I'll actually get an SSH session that will let me log into that node and I can start playing around with it. So you can do that while we're waiting for other stuff if you want. And there is a bug in the plugin of this for Chrome where it actually for some reason can't handle host names with dashes in them. So you will not be able to SSH into the source node because it has a dash in the host name. But of course you could also just run SSH yourself from the command line. You don't have to use this fancy plugin. So I showed you that I've got this little experiment running that's sending traffic, but of course I want to actually be able to see what's going on, right? I mean, in my experiment. So the next thing I'm going to have you do is if I go back to my Flack window here, so one of the tools that's been built on top of ProtoGenie is the University of Kentucky has built this InstaTools project that does a lot of automatic instrumentation where it will automatically provide you with traffic graphs and CPU load graphs and that kind of stuff. So we're going to take this slice and we're going to instrumentize it, which is going to set up a bunch of automatic instrumentation for me. So in the middle pane here, there's this little puzzle piece icon. This tab loads up the Flack plugins. Flack actually has a plugin architecture so that anyone who develops a tool that runs on top of ProtoGenie can write their own plugin. And I'm going to click. There's an instrumentize button on here. And go ahead and click this when you're ready. This one isn't quite as heavyweight as the first step. And what it's going to do is it's going to go out and it's talking to this Kentucky Instrumentation Tools project and saying, hey, okay, I've got this slice. I want you to automatically set up some instrumentation for me. And what it's going to do is, let me drag these back apart. You'll see that this new node just appeared on my canvas. So the architecture of InstaTools is such that what it does is it sets up a new node for me, and this new node is going to do it's going to collect all of the stats from my other machines. It's going to aggregate them. It's going to provide a web page that lets me view them. So what's happening is I sent my slice description to the InstaTools service and said, please tell me how to take this RSpec and instrumentize it. That InstaTools service then said, okay, well what you need is a measurement controller node. And so it took my RSpec, it added that measurement controller to it, and it gave it back to Flack. And Flack then it goes back to the rack and says, okay, here's what I want my slice to look like now. Please modify my slice to look like this. So it's, Vic, there's somebody who needs help in the corner there. So what's happening is another new node is being brought up that will that will act as this instrument controller. And if I look at it, there is really nothing special about this node. It just happens to be running a specific disk image. It happens to have a specific set of software get automatically installed, happens to have a specific startup script run. So I'm going to give this a minute, and while this is going, this is another good time. First of all, actually, let me ask, how many people are now sitting somewhere where I am, somewhere near where I am? Okay, the right side. How are things going over here on the left side? A couple errors. Okay. Well, let me come look at your errors and see if I can figure it out. Yeah. Yeah. Okay. That's pretty to the point. I'm actually not sure what the here. Here's what I can do. Let's see. Okay. Oh, sorry. So I'm gonna look at.
So we're seeing that in other places.
Okay.
That general fault, is that what was there?
Yes.
So
this is.
Was this the logins not getting created?
Yes.
And so
So that's it. I mean, there's not much.
Well, if we just reboot the VM from here,
That's true.
I think that will do it because it's a transient bug.
Okay. Let's see. So I should be able to do this. Okay, so let me just go ahead and say yes to that box. So we've had a couple people who have reported errors where a little dialog box popped up and said, error adding an instrumentation node. Where we have some transient bug that's being triggered by this many things going on at once. So if you get that error, there's this middle panel, and this is a good time as any to explain this. On this middle panel, there are 3 buttons down here once you have a slice. There's a play button. The play button boots up the machines in your slice if they're not already booted. The stop button shuts them all down. And the little reload button next to it reboots them all. So if you're having this error where it says it can't add the measurement controller, try clicking that little reboot button, and then when everything goes green again, try redoing the instrumentize. Yeah. No, yeah.
How do you create another node?
Yep, so you go to the puzzle piece, instrumentize. Yep, there you go. The SSH passphrase is the same as the certificate passphrase. So, let me answer this in case anybody else has this question. So if you're adding SSH keys and it'll ask you for a passphrase, the passphrase is the same one that you use. It's the same one that's written down as your Proto-Chini passphrase. It's the same one you used earlier. So, look at GSA. Yeah.
Do we need to connect this measurement tool to the?
Nope. It's doing exactly the right thing. Yeah.
Importing the.
Okay, go ahead and say no. So say no. So what was the last thing you did?
We just deleted it and resubmitted it
Okay.
because it was showing red.
Here, let's see. Connection closed. Okay, you had okay, so you guys are that's good. Can't connect to socket. Okay, so you guys had network errors.
Yeah.
See if your Wi-Fi is still working. I suspect your Wi-Fi is not working anymore.
We can't connect.
Yeah. Okay, so I have a bunch of people who are telling me that they're getting like socket connection errors. Can you guys verify and see if your Wi-Fi is completely broken or if it's just Flack?
The Wi-Fi dropped.
The Wi-Fi dropped. Okay. Okay. So if you're getting, so let me repeat this. Oh, is it gone? Is it gone for everybody now? Oh man. Okay. Well, I'm sorry. You're gonna have to just watch me do the rest of this because I'm on a wire. Let's see. Yeah. Okay. Let's see. So Vic. So you've already sent somebody to talk to him. Okay. All right. Okay. Well, I apologize to you folks. Apparently the Wi-Fi is just like completely dead. So I will walk you through the other stuff on mine. And if it comes back up, if somebody notices it comes back up, like let me know so I can tell everybody. So while I'm waiting for this last instrumentation node to come up, I want to show you a couple other features that Flack has. So first of all, I mentioned that there are all these other aggregates that you can get resources on. So the biggest one is this Utah Emulab, and this is a large cluster of about 600 machines that's at Utah, and it also controls nodes that are around the country in Internet 2 POPs. This advertisement takes quite a while to load because it's pretty large. Let's see, let me go back to full screen so you can see better. The wireless is back? Okay, so for anybody, let's see, let me try to think. So if you were if things were in progress and seemed to be working, I believe that if you click on your slice name on the left side, that should cause Flack to start reloading the state of the slice again. Because if it got that I/O error because it couldn't connect to the aggregate manager, it probably stopped polling. And I believe that clicking on the slice name should get it polling again. Okay. So you see, so I had the Utah Emulab. So the Utah Emulab resource has come up on the map now. You can see there's a couple of nodes in the I2 POP here in Houston. There are a couple nodes in the I2 POPs in Washington D.C., in Atlanta, in Salt Lake, in L.A. So you can use machines that are physically distributed around the country. If you want even more physically distributed, and these are connected by layer 2 links. If you want machines that are even more physically distributed, this plc.sa is Planetlab, which I would imagine that many of you are at least somewhat familiar with. If I load this up, it's going to show me all of the Planetlab nodes. So I can actually use Flack to allocate machines on Planetlab as well as the. Now these do, you can see these are not connected with any of those magenta lines, so they don't have layer 2 connectivity. And there are some farther away aggregate managers. This ANSP is in Brazil. It just came up I think about 24 hours ago. This USP is also in Brazil, and you can see as I'm loading more of these aggregate managers, I'm getting more and more things on the map that I can try to allocate. So let's zoom in on this. Let's see, so how are we doing? Mine is still going. Okay. What's happening, the reason this takes a while is that this measurement controller actually runs a fairly large software stack, including Apache and some SNMP daemons and MRTG and a bunch of other stuff. So it's installing all that right now. And all of us are running on 3 physical machines. And so these poor 3 physical machines are really getting pounded right now. So if you were to go and do this, even I guess there's several tutorials today. If you were to do this this afternoon or tomorrow, this would actually go much faster because you wouldn't be competing with 20 other slices. Yeah.
So another session tomorrow afternoon, people can stop by if they want to have completing the exercise.
Can you guys hear Vic? Do you want me to repeat that?
Yeah. So
Okay.
there's a experimental drop-in session tomorrow afternoon at 3:30, I believe. So if you want help completing this exercise, just stop by and we can have you complete the exercise. That's attention for resources.
Right. So while I'm still waiting for mine, let me show you one more thing, which is, okay, so these guest accounts, we'll shut them off after a while. And so if you want to, come and use and actually create and use GENI in the future going forward, what you'll need to do is you'll need to request your own account. So remember that I mentioned this is federated. There are a number of different places you can get accounts. The one that I would recommend that you use, because I'm the one who approves the accounts, is if you go to emulab.net. Here, let me just log out here. So if you go to emulab.net, which is one of the federated GENI sites, there is this button here on the left-hand side to request an account. And we have a project system whereby we as the facility approve projects, and then the leader of those projects gets to approve their own members. So the first person in your lab or team or university should say that they want to start a new project. We prefer to have faculty members, long-time research staff, somebody who's kind of stable and responsible and will be there for a while, start the project. It'll ask a bunch of information like what you're going to use it for, information about how to contact you, and make sure there is this special section under here under GENI account, and make sure that if you're going to use GENI that you fill this out. This is basically you're selecting the passphrase that you're going to use for your GENI account. And then once we approve that initial project with a project leader, everyone else can click this join an existing project, and at the bottom it'll ask you for the name of the project that your advisor or PI created, and then the project leader actually gets to be the one who says, yes, I really want to let my student do this or whatever. Let's see. Okay, so mine has finished instrumentizing. When yours does, it will look something like this. Basically, what it's offering to do is, so this instrumentation node is running a web portal that I can use to interact with it, and it's offering to take me to that. So I'm going to say yes, and it's going to pop up this map of. So you'll notice this is my same slice, the source node, the two sync/destination nodes, and if I click on one of these links, it gives me the option to graph. The two options I have are octets and packets. Let's go ahead and graph packets. And I'm not exactly sure what this message is, but it's safe to say cancel. I don't think any of the Kentucky guys are in here to answer it. No, okay. And so you can see on the left-hand side now, I've got these graphs showing showing some traffic, because my little experiment is automatically generating some traffic so that you would have something to look at. And I'm going to do this also. I'm going to do this on a couple of these other links. Let's go ahead and graph packets a couple places. And I can also click on nodes and do things like graph their CPU, graph their total amount of traffic, graph the packets on their various interfaces. And remember, a while ago, I showed you that I could go to this source node and click on visit to go to a web page that it's running. So I can use this web page, and again, this web page is part of my quote-unquote experiment, which is a silly little can thing that we built for you guys to play around with today. And I can do things like I can change the routes. And if I go back to my instrumentation tools portal, you're going to notice here in a minute, some of these have dropped to like zero traffic. Some of them should shoot up in traffic in a minute here. Let's see, which one's shooting up? I think this one's going to do it. And I can start and stop my traffic and watch that happen in near real time on my on my graphs. And actually, probably with the flaky wireless here and a bunch of us loading graphs at the same time, the graphs will probably load a little bit slow. But so, quick raise of hands. Has anybody else had their instrumentize finish? We had one. We had a couple. Okay. So at this point, I mean, I want to use the rest of the 15 minutes that we have to answer questions about the process that went on here, or the resources that are available, or what kinds of experiments you can run. So I'll take questions. Yeah.
Well, so when we define these, let me say slides, so how I can define my applications and link these applications to the resources, and first of all define what kind of protocol stack I would like to use for communication.
Yep, got it. Okay, so the question was how do I define my application and link it with individual hosts that I've allocated, and how do I define the protocol stack? Get that right? Okay. So, so there are, I guess, 3 main ways to load the application on here. So the machines that you're getting from InstaGENI or from any of the other GENI resources are fundamentally just Linux machines, BSD machines, Windows machines, whatever operating system you asked for. So one thing you can do is you can just copy stuff over yourself, right? You can just fire up SCP, copy your application over. Another possibility, of course, so this is like a reasonable way to get started, right? You compile it, you copy it over and test it out. You change it, you copy it over again. Once you're a little bit more confident that you've got the right software put together, then you can put it all in a tarball and stick that tarball somewhere on the web. And you'll notice, sorry, I did that quickly. I should slow down and show you what I'm doing. If I click on the information button on one of these nodes, you can see that our tutorial, we stuck the software that we were going to use for the simple little experiment in a tarball. We put it on the web. When I went and when I instantiated this, it downloaded this tarball and stuck that tarball on every single one of the machines. So this is a way, if you have a medium-sized amount of, if you have a megabyte of software or something, this is a reasonable way to load it. And so, finally, if I want to make some substantial changes to the operating system, I want a bunch of packages, I want to replace the kernel, then what I would do is I would log into one of these. I would log into one of these machines after I had it created, and I would go and I would install my packages, and then I would use Flack actually has this little create image button that will take a snapshot of the current state of that disk, and then I can load that on machines in the future. If I want to run a protocol stack that isn't IP, for example, again, because these are just Linux machines or whatever, essentially you're free to reconfigure them however you want, right? There are some various experimenter tools. Flack doesn't go to a lot of effort to help you with that kind of thing. There are other tools. I don't know if there are any of them that really help you automatically set up non-IP protocols. But there are some that certainly will help you, provide you with more support for installing packages, orchestrating the starting and stopping of various things. For example, there's a tool called Gush that I don't believe there's a Gush tutorial at this GEC. There have been at previous ones that will kind of help you with the experiment management lifecycle. But so fundamentally, if I want to run if I want to run what? If I want to run OpenFlow, for example, one of the things I can do is I can take the machine that I got and I can install Open vSwitch on it, and which is a software OpenFlow implementation. There are many places in GENI where hardware OpenFlow is supported. that's kind of like beyond my scope to explain how to use that stuff. But yeah.
If I would like to use OpenFlow with SDM,
Yeah.
define the connectivity between switches.
Correct.
So I couldn't see on the picture which you demonstrated to us, I just see the links.
Yeah, that's right. Okay.
It's a virtual links. I couldn't see any switches at all.
Yeah. So the question was, if you wanted to use OpenFlow, you would need to actually know about the connections between physical switches. So if you're going to use a software implementation of OpenFlow, then actually what I would do is I would run the OpenFlow software, a software switch on every one of these things. And in fact, these would be the switches, right? If what I want to do, there's an OpenFlow mesoscale backbone that connects a bunch of the GENI sites. Flack basically doesn't know how to configure that backbone. There are another set of tools that those guys have developed for for configuring the OpenFlow backbone switches, and you'd have to use those, and I'm not familiar with those, so I can't say much about them. Let's see, any other questions about the resources that I've got allocated or the process of using them? Have people successfully instrumentized now? Yes? No? No? Okay, we're still waiting. Yep. What's that? What were you asking? I'm sorry, what?
I was lost at that creating new server, but can you show up again?
Okay, so I had somebody add a request to show people how to do the instrumentized status again. So if you've just got the 3 nodes that are connected by the LANs and you want to add this other instrumentation node, there's this little puzzle piece, which is the puzzle is for plugins. The instrumentation tools is one plugin. Oops. No, I don't want to print. And so what I did was I went to here and I clicked on this instrumentize button, which caused that extra node to get added and the instrumentation tools to be set up.